Friend, today I want to explain lesson number 2 science, a topic related with already we have completed the topic related with the science, that is acid and base. Today I want to explain more something related it, that is we now go on indicator. We have completed acid, base and salt. Acid we have completed, base we have completed, and salt we have completed. Example of salt are sodium chloride and potassium chloride. These are all the example. Today I want to start related with the indicator. What is the meaning of indicator? It's a one type of a substance which change their color or smell in different type of solution. When we add it, simple example is there. If acidic solution is there and if I add phenolphthalein, then colorless means no change in the color. But if I will add in the base phenolphthalein, then it will be changed into the pink color. So that is one called indicator. So today we want to first understood definition of indicator, then types of indicator. What is meaning of type? There are three type of. One is called natural, that is we found naturally, that is found in nature. If you will see the smell of rose, smell of marigold. So these are all the related with the nature indicator. Or we can the smell of leaf cabbage, that is flowers of hydrangea plant, that is mainly water of maximum water is there in the plant, and it's one type of marigold type plant, and turmeric that already we have used in the our kitchens. So today we want to discuss with the three topic, that is first natural indicator, second is synthetic indicator, third is olfactory. Synthetics means which we are made chemically, that is called synthetically. Olfactory means the different order. If you will see the different type of order, that is called smell. If we will in our kitchen, there is a one good thing is making by our in our house, then it has a good smell, we say that. So we can say in perfumes we have see different type of smell, that is related with the your acid and base. So three type: natural indicators, synthetic indicator, and olfactory indicators. So naturally from plants, litmus paper, we say that when acid change into base, litmus paper color is converted into red. So when blue turns to red, we can say acid. So that way, and chemically, that is methyl orange and phenolphthalein 2 mostly used. EDTA, another synthetic, E, capital E, D, T, A. They are one of the most broadly used in titration in laboratory. So now we want to give deeply. Natural indicators which are litmus. So litmus paper, color of the acidic solution is red. When acid is there and if you put litmus paper in it, then it will be turned into red. Smell or color of the acidic solution. Or when base is there, it should be blue. When sodium hydroxide is there, NaOH in beaker, if I will put NaOH solution at here, and in the NaOH solution is here, NaOH solution, sodium hydroxide or NaOH solution. Now it is a base. We know that NaOH solution is a base. Now if we put litmus paper, it will turn into blue. So that is an example related with the litmus paper. Red cabbage leaf, when acidic solution is there, it convert to red, or it should be in green. Flowers of hydrangea plant. Flowers of hydrangea plant first found in Japan. It requires more water, so it's one type of marigold. In acidic solution it is blue, in basic solution it is pink. Turmeric, no change. When acid is there and if we add turmeric, there is no change, but if base is there, and if we add turmeric, it will be red. In our house there is a soap solution. Soap is always base, and if we add turmeric powder or turmeric, it will be converted into red. So it is a natural indicator. Now synthetic indicator that we are used mostly, phenolphthalein. When phenolphthalein is used, when acid is there, HCl is over acid. then if we add phenolphthalein, there is no change. But when it converts into the base, that is NOH, and percentage of NOH is increasing if we do the titration of acid base. In beaker, if I will take acid, and if from flask or in flask I will take acid, and if we add NOH, if conversion is basic, then the color is pink, because already we have added phenolphthalein 2 to 3 drops. So now same thing, methyl orange. When methyl orange is there, when acid solution is there, it will be converted into red. If acidic solution is there, if I add methyl orange, we know that it is acidic. Or if we convert into yellow, then we say it is a base. Sodium hydroxide is one of the example. Olfactory, that is order. Olfactory, that is order. So in order, if you will see that onion, already we have a particular same of onion. So when acidic solution is there, characteristic smell we have. It means the characteristic of onion already present if acidic solution is there. But if base is there, then no smell. Means we identify that the solution is base or acid. Vanilla essence. Vanilla essence retains smell. So we can get the smell of vanilla if acidic solution is there. But no smell, then we can say it is a base. Clove oil, that is retaining smell or lose the smell. If acid is there, then clove oil, if clove oil હોય તો એના retain smell રહે, અહીંયા એની smell વહી જાય. So these are topic related with the only indicator, acid, base and salt. And now these are all the topic related the acid, base and salt. So first of all we have to name of the acid. The acid HCl, hydrochloric acid, H2SO4, that is sulfuric acid, H2SO4, that is sulfuric acid, and HNO3, that is nitric acid. These are all the strong acid. Now weak acid is acetic acid, CH3COOH. Now these are all the acid. Now you want to discuss about the base. Now base, that is NaOH, is a strong base. KOH, that is also a strong base. And NH4H, ammonium hydroxide, that is weak base. Now we can do the titration of all. If acid is there, and if I will put synthetic in that phenolphthalein, then colorless. But if it is base is there, it is pink. When acetic acid is there, these are all the acid. Even if acid solution is there, if I will put phenolphthalein in it, then it is colorless. But if I will put methyl orange, then it will be converted to red. All base are there. If in this base NOH, KOH, NH4H, if I will put phenolphthalein 2 or 3 drops, it convert into the pink. If I will put methyl orange in the solution, it will convert into the yellow. So if you will see in your example exercise, these are all the example that in one activity it is the name of the acids and base are given, and you have to convert, you have to give the answer that what is color change. So if we will go for first lecture, that is acid, base and salt, and the one more topic, that is indicator. So you have to write these indicators compulsory. You have to write all the indicators, and then you have to write the acidic solution, basic solution from here. It is important chart, it is not available in our text. So anyhow you have to do this in your rough book. Now we want to, in next lecture, we want to start chemical properties of acids and base. That we want to start. Again I am say to you, you have to compulsory watch this video and make comment, so I know that you have watched it. Otherwise I don't know how you are watching. So compulsory you have to watch until the last. But already we have discussed that we want to start today chemical properties of acid and base. We want to start chemical properties of acid and base. So first of all, we have to, from this lesson you have to also write the chemical formula related, important chemical formula related it. So chemical properties of acid and base. So reaction of metal with acid. So first, chemical properties of acid. When we react acid with metal, what happens? So when acid reacts with metal, it gives salt and hydrogen gas. One of the example is given. So 2HCl plus Zn gives ZnCl2 plus H2. Reaction of acid with metal. So here Zn is a metal, but in our text there are more examples related it. Now if base is react with metal, when a base is react with metal, it gives salt plus hydrogen gas. So both if you will see that here it is, when hydrochloric acid react with zinc, it will give zinc chloride plus H2 gas. So here gas is liberated. So we have to make a rule like that. When more example is sodium hydroxide is also a base. When base react with Zn, it gives sodium zincate. It's a one type of salt. Sodium zincate chemical formula may be asked and liberate hydrogen gas. Hydrogen gas release can be tested by bringing burning candle near gas bubble. It bursts with the popping sound. So it is the most important characteristic that present show the presence of hydrogen gas. When hydrogen gas is present, what we have to import popping sound is there. So if we bring the burning candle or matchstick near gas bubbles, it will burst with the popping sound. So most example, so simple, when as reaction of a metal with acid or base, it liberate hydrogen gas with popping sound, and it's acidic salt and your basic salt. Clear? So in our textbook same reactions are there. Now reactions of metal carbonate and metal hydrogen carbonate with acid. So first of, what is the meaning of metal carbonate? Carbonate means CO3. When CO3 is there, it is called carbonate. Metal means sodium, hydrogen, potassium. You can write it. So that is a so metal salt, but carbonate is there. When hydrogen carbonate is H. Now metal carbonate with acid gives salt plus carbon dioxide plus water. Important is salt. Again metal with acid. Here one example is there. When acid react with metal carbonate, NaCl, CO2 plus H2O. Further it is not possible. HCl and NaHCO3, that is called metal hydrogen carbonate. So metal hydrogen carbonate, it gives NaCl plus carbon dioxide plus water. CO2 can be tested by passing it through the lime water. How we can know that at the end of reaction that carbon dioxide gas is liberated? If we collect this gas and pass in the lime water, it turns milky. Then we can say that the carbon dioxide gas is liberated. When excess carbon dioxide gas is passed through it, it will be again milkiness disappear. Again, we have to discuss about when reaction of metal carbonate and metal hydrogen carbonate. Metal hydrogen carbonate means HCO3. So when metal is react with metal or metal hydrogen carbonate, it will be give salt, carbon dioxide and H2O. Now metal plus base plus metal carbonate or metal hydrogen carbonate, no reaction. That is you have to remember. Mostly in your text that is not properly given. So our concept is what? Metal with acid with metal carbonate or metal hydrogen carbonate, it gives salt, water and carbon dioxide gas. Now acid with reaction of acid with base. That is most important, because you have to write a short note on neutralization reaction. That will be asked in your exam. Reaction of acid with base is called neutralization reaction. Reaction of acid with base is called neutralization reaction. HCl plus NOH gives NaCl water. So here it is salt, here it is acid, here it is base. Now there are four different types of reaction it has. When strong acid with weak base, then salt is acidic. Salt is acidic. Again, strong acid with weak base. If I will take weak base, then it is acidic salt. That already in our text. Because strong acid has more concentrate of it, so acidic salt. Weak acid and strong base. Who is strong? Base is strong. So basic strong salt. When strong acid and strong base, it is called neutral. So neutral, NaCl is neutral. So it is eatable. That is why we are using in our kitchen. When weak acid is there and weak base is there, again it is neutral salt that we also use. And product is H2O. So these are all the, if you will see in your textbook, more example are there. Again, strong acid, strong base, that is example. Now strong acid, if you will see, we can take HCl as a strong acid. But now due to weak base means we can take NH4OH, NH4OH. It's a weak base. Strong acid, weak base. Salt is acidic, that is NH4Cl, NH4Cl plus H2O. So you will say it is acidic salt. So strong acid, weak base, we can understand this by this type of reaction. In your text, these reactions are given. One more, so three reactions to now weak acid and weak base. So CH3, CH3, COOH, that is our weak acid. Now weak base, already I am written here, NH4, NH4OH. Now if we make of it, then CH3, COO, N, NH4 salt. So it is a neutral salt. So the type of reactions already in your text, but maybe possible that they ask in exam, write a short note on. Write a short note on neutralization. You have to write the reaction of each, strong with weak, weak with strong. So 4 reactions at least you have to write. So to be today's topic related with the acid base reaction, salt and water, and reaction of acid with metal carbonate, metal hydrogen carbonate. In base there is no reaction. When metal carbonate react, it liberates carbon dioxide. And when reaction of acid with base, reaction of metal with acid, it liberates hydrogen gas. Reaction of metal with base, again it liberates hydrogen gas with base. So basic salt, sodium zincate, acidic salt, sodium chloride. So this is sufficient for us. So there is no online lecture, so we can put this as a lecture. Thank you. Again, you have to read this, you have to make a comment, so we can know that you are using this.